Welcome to the first forecast and update video for now Tropical Storm Melissa out over the southern Caribbean right now to the directly southeast of Jamaica right now, moving to the really north, but eventually west here at about 19 Zulu on 10/24/2025. That is October 24th, 2025. In this video, we are going to be discussing the potential tracks and intensity of Melissa and maybe some of its limiting factors, as well as some of the factors that could help generate an absolute buzzsaw of a hurricane out over the southern Caribbean here in this upcoming weekend and early next week. So let's go ahead and dive right into it. As you can see here, over the past couple days, Tropical Storm Melissa has gone from a 80% development region out here north of South America. It has moved off to the west and become a tropical cyclone yesterday evening out here south of Haiti and the Dominican here. As I speak right now, it's about 3:20 Eastern time, so 19 Zulu, as I've already stated. We have Tropical Storm Melissa at 60-mile-per-hour sustained winds here directly south of Haiti, directly to the southeast of Jamaica right now. It's moving east-southeast at 2 miles per hour. That was a couple hours ago, so 2 p.m., so about an hour and a half ago that this was updated. Now it's starting to take a jog to the north as we have a little bit of convective development here on the northern quadrant of the tropical cyclone. I do expect, like I said, it's going to take this northward jaunt, and then it's going to continue to move to the east for the near term. So like I said, we have Tropical Cyclone Melissa, currently not very significant, 60-mile-per-hour sustained winds, moving east-southeast at 2 miles per hour. However, we do expect pretty rapid development here as we go overnight into tomorrow and then in the weekend as it moves eastward towards Jamaica. As you can see here, the National Hurricane Center has this becoming a hurricane by tomorrow evening and then a major hurricane by early Sunday. Now, I do expect this to become a major hurricane earlier than the National Hurricane Center predicts. I'm going to say maybe even tomorrow evening we'll have a major hurricane on our hands southeast of Jamaica. Speaking of warm waters, the water sitting over the southern Caribbean is an absolute bombshell waiting to go off. As you can see here, we have 30 to 31 Celsius waters for much of the southern Caribbean basin here, south of Haiti, south of Cuba. This water is absolutely explosive, and right now Melissa is sitting right about in here. And as you can see here, just around Jamaica is where really the most explosive water is sitting, and hurricanes love very warm water. In order to get a significant hurricane, really we're looking for high 20 degrees Celsius waters. We're talking about low 30 degrees Celsius water. This is extremely warm. This is about 90 to 92 degrees Fahrenheit over here across parts of the southern Caribbean. That is bath water. So Melissa is working with a lot of energy sitting over this basin here. And if she really taps into that, this could be a very, very ugly hurricane given the low amount of wind shear that is going to be stationed over this area here in the coming days. Now, reflecting back onto satellite, you can see that Melissa is starting to close off her low. So let's go ahead and take a look at infrared satellite. And as you can see here, let's go ahead and actually pause. We're going to pause this loop. This was just a couple minutes ago, about 20 minutes ago, I believe. And as you can see here, Melissa is starting to close off her low. You can see her center is probably somewhere right in here with very cold cloud thunderstorm tops going up all around her center. indicative of very strong convective development. So the taller they get, the colder those cloud tops are going to get because the higher up in the atmosphere they are. And as you can see here, they're very, very cold. So this is indicative of very, very robust convective development around her center. And you can see just an absolute textbook cyclone look here with Melissa at, again, 3:30 p.m. Eastern time. Taking a look here at visible satellite, I just want to, there's not too much to mention in the way of meteorology here, but it's just absolutely a gorgeous, gorgeous tropical cyclone. Can't say hurricane yet, tropical cyclone here out over the southern Caribbean. Just a beautiful center here, and you can see, I want you guys to notice here these gravity waves with kind of just convective explosion. You can see gravity waves. They look like waves of the atmosphere. Let me see if I can pause this so you guys can kind of see here what I'm talking about. Right here. Look at how this is just absolutely fascinating phenomenon here with Melissa. You can see these beautiful textbook gravity waves ejecting out from her center due to explosive updraft and convective initiation here around the core of Melissa. And then you can see extended out here, we maybe have another band of convective storms starting to pop up Melissa's center. So just gorgeous textbook storm. Again, beautiful storm out over just amped waters for a hurricane. Now, okay, and yeah, again, Melissa looks like it will become a very strong hurricane owing to the extremely warm water sitting out here over the southern Caribbean, as well as the minimal wind shear that she will be working with. As you can see here, early in her life, you can't see any colors. There's not going to be very strong flow out here over the southern Caribbean. It's all going to be up here into the contiguous United States, down into Mexico, and out over the northern Atlantic. So not much wind shear that Melissa will be battling. And again, extremely warm, very explosive waters conducive for a major hurricane. And here is a spaghetti plot of the possibilities of the intensity that Melissa could achieve. Now, looks like most models are honing in here on a high-end Cat 4 to Cat 3 hurricane come this weekend. So come about Sunday, most models have this peaking here in the high Cat 4 range. But I would go to say that if conditions are met, if possibilities for Melissa are met, I do think that she can make a quicker, more steeper intensification up to a Cat 5 and remain a Cat 5 until it makes landfall somewhere, or it just goes on for a long time in the southern Caribbean and eventually fizzles out because it's not moving very fast and it uses all of that water up, all of that warm water at the surface. So if a hurricane stays over, let's go ahead and do a little schematic over here. So for we have warm water here at the surface, and let me just draw that in red. So we have this very warm water here at the surface, and it extends a couple feet, couple meters deep, and then below that we have much cooler water. And let's go ahead and just draw the hurricane. We'll draw the eye of the hurricane here with this is all the conjunction and the clearest eye. So when this hurricane is using up all the energy from this warm layer of water here, and the way the surf becomes very choppy, what the hurricane actually begins to do is mix up this cold water up to the surface because of the choppy surf and low pressure actually absorbing some of the top layer of the water. This is a process that we call upwelling, and this actually causes cooler waters to rise to the surface and therefore a lot less energy available to the hurricane. So if a hurricane sits over a particular point in the ocean for too long of a time, it will start to fade in intensity owing to the less amount of energy that will be left in the water. a couple months ago when we saw Aaron move towards the contiguous United States. You can see in its path a cold streak of water. That was also due to upwelling. And with this hurricane not looking like it's going to move very much, I do think that if it stays stationary for too long, it may not reach its full potential. However, if it does start to take a more quickly east northeast jog or west northwest jog, excuse me, it may just may reach its potential as a very, very strong hurricane. So now let's go ahead and take a look at some of the possible tracks here for Aaron and why I think and why I agree with the models that it will take this track. So as we can see here, Aaron is currently situated, actually it's a little bit farther southeast than that currently. Aaron is situated here out over the Southern Caribbean, south of Haiti and the Dominican. I do expect Aaron, sorry, why am I calling it Aaron? I do expect Melissa to take this path here that the models are projecting. This is an ensemble spaghetti, so these are all the models, all of the potential tracks of the center of Melissa congealed into one map here. And as you can see, they're all agreeing that it's going to take a hard turn to the northeast, right about when it gets to Jamaica. So Jamaica, you definitely need to be watching out because this is going to be a major hurricane when it's impacting the eastern part of Jamaica here. So Jamaica, heads up, a lot of rain, maybe significant winds. We aren't sure yet, but if Melissa is able to reach her potential, then you will be dealing with a very major hurricane, but nonetheless, a lot of rainfall. So why is it that Melissa is going to take this hard turn to the right here in the upcoming week? That is because of steering flow. Let's go ahead and take a look back here at our 500 millibar wind speeds. And I'm going to go ahead here and plot out the track that the spaghetti model was hinting at. And let's go ahead and take a look at why. So as you can see here, we have a belt of stronger flow situated up here over the contiguous United States, reaching over into the Florida area and then over the northern and central Atlantic. So we have that belt of flow here, and it's not really affecting Melissa early on in her life, like we talked about. Not a lot of shear, very warm waters. A possibility that she will rapidly gain intensity and become a very major hurricane here in the coming days. And then as time goes on, this is next Tuesday and Wednesday here, you can see that this belt of stronger flow is going to start to dip here into Melissa's regime and start to interact with Melissa. We can go ahead and take a look back here at the American since it goes out a little bit farther. And you can see here that this belt of stronger flow is actually going to Melissa's kind of going to embed herself here into this belt of stronger flow that's interacting with her wind regime here. And that is going to effectively shunt Melissa off up here into the open Pacific. So again, belt of steering flow. I absolutely agree with this ensemble here. We're going to have that belt of flow dipping down into here, and that is going to launch Melissa out to sea here after she is nearly stationary over the Caribbean for several days here. Sometime in the Tuesday to Wednesday timeframe, we will see Melissa start to get shunted off here into the Northeast Pacific by that 500 millibar flow. Go ahead here and take a look at a couple more loops of this gorgeous tropical cyclone, and you can start to see actually another round of gravity waves start to be emitted out of this center of Melissa right now as we speak. Just very textbook tropical cyclone starting to intensify here as the sun is setting over the southern Caribbean. So thank you guys for watching. I hope you enjoyed. We will have more forecast videos out probably early next week when we know a little bit more information about maybe the potential, the max potential of Melissa. But right now, the bottom line is we have a developing tropical cyclone over the southern Caribbean with very warm waters situated out ahead of her path, and a not a lot of wind shear right now, but eventually we will have some steering flow mixing down into the southern Caribbean, down into Melissa's regime, shunting her off to the northeast. So I don't expect anything to do with an American contiguous United States landfall, but Jamaica, Cuba, Haiti, Turks and Caicos, all those Antilles Islands, you need to be watching out for definitely very heavy and torrential rainfall, but maybe a high-end major hurricane as we work into the end of this weekend into early next week. Thank you for watching, and be sure to like and subscribe for more content like this. Like I said, we will have another update video out early next week. So I know I mentioned a lot about hurricanes and wind shear and how hurricanes don't like wind shear. Now, this might seem counterintuitive because, as many of you may know, or many of you may not, wind shear is an essential component to severe thunderstorms and tornadoes. A lot of people equate hurricanes with likewise severe weather. So hurricanes do not like wind shear. Wind shear is very much a negative force when it comes to hurricanes, and this is why. So I have a little schematic here drawn up. This blue down here is the ocean, and then this black here is the convective development within a hurricane, and where this little channel here is the eye. Now, hurricanes strike a very delicate balance between inflow and outflow. And so it's sucking up this energy from the warm, humid water below, layer of air just above very warm ocean water below, and it draws that up. It draws that up through this low pressure, which is the eye. And now this has to be a very delicate balance. And hurricanes cause this. Hurricanes regulate this process themselves. When it comes to wind shear, what wind shear is it's a change in direction or um, value of it's a change in direction or wind speed with height. So if we have a 10 knot wind at the surface and a 50 knot wind in the mid levels, what that effectively does is it will tilt the storm. And so it's pretty easy to see here why hurricanes don't like wind shear, because if it wants a vertical column here with a low pressure situated in here, drawing up that warm air and evenly distributing outflow out of the top, then if it's tilted, it's not going to be able to efficiently do that. It will be extremely uneven. And so hurricanes really very much dislike wind shear. Another thing that wind shear will do is if you have a bunch of dry air here, hurricanes obviously hate dry air. Same thing with thunderstorms. And what wind shear does is it will entrain this dry air into the hurricane, and that will be very detrimental to a hurricane in its development and maintenance stages. So that is why hurricanes don't like wind shear.